another problem session. Actually, we've done this problem before, and because this cursor, when I was recording earlier, it did not have this highlighter, so I think it's hard to follow that video, so I'm going to just do it again. So here's the problem. So we have a wedge, this block, and it's kind of fixed to the bottom of an elevator. So see, it's the bottom of the elevator. This is fixed to elevator, and elevator itself is going this. So the wedge, when you say it has an acceleration, clearly it has an acceleration with respect to, maybe over here is ground. Here's ground. And this is at some time t. Okay? So like this x-axis and this is the y-axis. Okay? And this, so if the elevator is moving, the wedge is moving. If the elevator acceleration a, the wedge acceleration, same acceleration a. We use capital letter for that. So that's given. And a block can slide on this, all right? And maybe block was here at t equal to 0. And the wedge, this angle of the wedge is given. Maybe also given is block at height from the elevator initially, and maybe let's call the base side B, all right? So the block was here at t equal to 0, but at time t it's over here. And we need to find the acceleration at time t. So the question can be, find a at time t. You can find v at time t. You can find position at time t. So you can find these guys given v at 0, maybe start at rest just for simplicity. And this will be given r0 is at top. And we can define top as we go, okay? So that's the question that can be asked. Oh, so I've talked about this, that if you have a choice to say, I am going to have, I'm just going to have a frame which moves with the block, or wedge, I mean. So here's a wedge. I can have a frame that actually is maybe over here. So let's see. This is the y prime axis, and this is the x prime axis, and its block is here at some time t. And so block is x prime, y prime at time t. So the prime means this is a new coordinate, and this guy is unprimed. So this frame will be inertial frame. But a frame which, with respect to the inertial frame, this is the inertial. So non-inertial frame, this actually is moving with respect to the inertial frame, has an acceleration a. So if you write f equals ma for this, so if you write, say here the acceleration is prime, so if you write f in the unprimed frame, equals to mass in the prime frame. So if you write like this, then okay, so you can write like this, and suppose you write over here F in the inertial frame. So this is correct. So this F here, if you look at the forces with respect to this guy, there are only two forces, but whichever frame you look at, there's gonna force normal and then gravity force. So this is the, let's see, weight vector, and this is the normal vector. And so F is just a normal vector plus weight vector. And this is also just normal vector plus weight vector. But so this formula turns out to be incorrect. If you're because clearly you can see acceleration here is with respect to something that's not moving, right? The block is not going anywhere, so it's with respect to the block. I keep saying block, with respect to this wedge, let's call it, and this name of this guy will be block. With respect to the wedge, but here with respect to the ground, so this acceleration is not equal to that acceleration. Acceleration prime is not equal to acceleration, but F prime is equal to F. So one of them is wrong, but this is the correct one. So if you put A prime in terms of A properly, then you can actually solve it. You can say, okay, so what's the difference between A prime and A? How can I make this guy, this looks much simpler than in writing because setting it up, etc. How can I do it? Let's address that. This is called doing physics in a non-inertial frame. That's a O prime, X prime, Y prime frame. So this is O prime. The way it's going to be is, so if you look at this guy, so that's the vector R prime vector, and from here to here is R vector, and from here to here is little r vector. So the O prime as person R. So if you look at these three vectors in space, so this is a position with respect to O prime, and this is position with respect to O. So if you look at this vector wise, you get to R by going through this and this. So now take a time derivative. So if you do ddt of this, then the velocity with respect to this guy will be the velocity of the frame. So this frame has some velocity v at some time t. We're all talking about time t. So this will be the v, capital V, of the non-inertial frame, and little v prime with respect to the non-inertial frame. So this is the velocity of the non-inertial frame. And do ddt one more time. This is v. So finally we arrive at acceleration is equal to acceleration vector plus acceleration prime vector. So you can see that A prime vector is just A minus A. So I go out there and say, hey, this side is just F. So only problem is this guy was not that. So to correct that, so here I should be able to write F equals to mass A prime, but this A prime is this mass A plus, don't start from there, start from here, because this is correct one. So we start with the correct one. So we had F equals to mass A, this is the correct, and so I put A in here, and then we're gonna get F equals to mass A plus A prime. So it should be the correct formula in the non-inertial frame will be, so whatever the force you have, you got to subtract this quantity from it, then it will be okay. So this is, so you can look at this here. F was normal plus weight. These are two forces here. So the original force, and then we have to add a negative of ma of the frame itself to get mass times acceleration in this frame. So these are our what we call real forces. Okay, and this thing with the negative there is called fictitious force. Okay, so in our case here, in this here, we just need x and y component. So doing in our case, let's do O prime, y prime, block is that way, and so weight is that way, normal is that way, and this is 90 degrees, this is theta, so this angle is theta, this angle is theta, this y prime, x prime, right? So and our A is just A in terms of component, x component 0 and y component is A. A prime is just A x prime, A y prime, and n has x and y, is n sine theta, n cosine theta, and w is just 0 minus mg. So those are the components. So it just turns out to be max prime equals to n sine theta, that's it. May prime just turns out to be n cosine theta minus mg minus ma. So another aspect of this whole thing is, no matter x and y is going to have to lie on this line. So on this line, what is the equation of this line? Because of constraint, you can see this is b0 and this is 0 h. So y prime minus h over x prime minus b, right? So that's this b minus x prime, b minus, this is, so in that triangle, so this is y prime. Oh, what did I do it? That's not do equation of line that way. So we have equation of line this way. So we have a x prime y prime, and you can do it quite different ways, right? So this is b0 and this is 0 h. The slope is going to be minus h over b, and it's going to go through this point. So y prime minus h equals to minus h over b x prime, when x prime is 0. So like x prime is 0, y prime is h. When y prime is 0, x prime is b. So you can check this is correct. So y prime is h minus h over b x prime. So y prime is going to be 0 minus h over b y prime, v x prime. Take another derivative, a y prime equals to minus h over b. H over b, this is theta, that's going to be tangent theta. Y prime equals to minus tangent theta a x prime. This side is x prime. So this is ax prime. So we can write down a y prime equals to minus a x prime tangent theta. So over there, turns out to be max prime equals to n sine theta, may prime plus mg plus ma equals to n cosine theta. And so this one can replace m minus m tan theta ax prime. Now take a ratio of this. M cancels out. So you have ax prime tangent theta minus of that plus g plus a over ax prime equals to this over that is 1 over tangent theta. Do it like that. So you have a minus ax prime tan square theta plus g plus a tangent theta equals to ax prime. Bring this on the other side. So ax prime 1 plus tangent square theta equal to g plus a tangent theta. And so ax prime, this is sec square, over there's cosine square, g plus a tangent theta cosine square theta. So g plus a sine theta cosine theta. This is g plus a over 2 sine 2 theta. So this is ax prime. And similarly, a y prime can be just minus tangent theta of that guy. G plus A sine theta cosine theta tangent theta. Tangent this will become sine, and this is sine squared theta minus G plus A sine squared theta. So this is how you can do, and if you look at which direction it will be, of course AY prime over AX prime is going to be minus tangent theta. So it's going to be right here. So it's built into that, is going to go down that direction or up that direction depending on, you know, if you're just letting go, the way we let it go, acceleration will be pointed down like that, down this. So it's very natural to do it in a non-inertial frame. So doing physics in non-inertial frame is often very natural, but you have to willing to modify the equation this way or this way. So in a non-inertial frame, equation will become, instead of f, then you have to add a fictitious 4, then you'll have MA. This will be non-inertial frame, and this will be, of course we go to prime here, but you know, let's call the prime just for the sake of today, but you don't have to remember that as a prime, non-prime, those things are just up to us. And this is just equal to mass times acceleration. This is the acceleration of the frame itself. So this is the way we'll do it. Okay, let's do this out in inertial frame, like the way we did before. So here is, so doing this inertial frame. So inertial frame is like that. Y, O. So now the block is at X and Y, and this point is at some, so this is a function of time. Wedge is located by this point, and the block is located by that point, and this instant t, this is theta. So this is X, this is B, and so this part is B minus X, and this part is Y minus capital Y. So real Y minus capital Y over B minus X equals to tangent theta. So this was a constraint, and there was a similar constraint that we wrote down here. That's the constraint in that system. So here is Y minus Y. So this is time dependent. This is time dependent, equals to B tangent theta constant minus X tangent theta, and this is time dependent. So if you go to the acceleration, AY minus AY equals minus AX tangent theta. So AY equals AY minus AX tangent theta. That's the connection. And because this guy acceleration pointed up with an A, and so this is AY for us was simply A. Okay. And now we don't have any problem. We can write F equals to MA. No fictitious forces. Because inertial. Okay, so now we have for the X component, mass times AX, it's just F is N W. So X is this theta is same as that theta, and sine theta almost identical, equals to N cosine theta minus mg. And we've done this before. Let me do it again out. So this becomes M AY minus MAX tangent theta, and then bring this on the other side plus mg cos N cosine theta. Take a ratio. So MA, call this A, MAX and cancels out. The M is in every term upstairs, and same as downstairs. They all cancel out. And this I can write as 1 over tangent theta, because we have tangent theta over there, and just bring it easier. So A tangent theta minus AX tangent square theta plus G tangent theta equals to AX. Bring this on the other side. So A plus G tangent theta equals to AX sec square theta equals to cosine square theta, and bring the other side. So that solves for AX equals to A plus G tangent theta cosine square theta, and this just will become this was sine theta cosine theta. So this is A plus G sine theta cosine theta, and that A plus G over 2 sine 2 theta. So you can write like simple form like that. And AY will simply be, we just have it from here. AY, A minus AX tangent theta minus AX tangent theta, and this just putting this in there kills that, makes it A minus A plus G sine theta cosine theta, and writing this as sine theta per cosine theta. So A 1 minus sine square theta minus G sine square theta, and this simply becomes A cosine square theta minus G sine square theta. So we have this this problem, and which is different. Let me summarize. So ax equals a plus g sine theta cosine theta, and ay is a cosine square theta minus g sine square theta. And the prime, guys, we found is x prime was same. So x in the prime was same. And that kind of makes sense, right? Because acceleration of the frame is in the y direction. Ay prime is this instead. So it's minus g plus a sine square theta. So we can write down minus a sine square theta minus g sine square theta. So if you're going to write that as add a, want to compare with that, add a and then subtract a. So this will be, this part will become a cosine square theta minus a minus g sine square theta. So this becomes ay minus a. Kind of makes sense, right? If you look at the two frames, if I go back how the two frames were related back here, when we had, that was the relation. A prime was a minus a. A minus a. That means ax prime was equal to ax. So generally, we had that relationship between non-inertial and this was inertial, minus ax, which is equal to 0 here. So this is just ax, correct? Ay prime equals to ay minus ay, which is ay minus a here. That's also correct. So everything works out. That's really great. Everything worked out. As long as, now it's kind of shouting big capital letter, as long as you keep track of whether you are working with respect to an inertial frame or a non-inertial frame. Okay, so this is great. I'm glad everything worked out and I didn't make any stupid mistakes. I just want to have a request that you subscribe to this channel and maybe tell your friends, spread the word about this channel. It's kind of helps get the word out that there is a channel where somebody is solving problems in a very complete way, and you may be learning something, maybe other people can learn also. All right, take care. Bye-bye.